Ladies and gentlemen, if you're trying to find the derivative of a product, this is an error and this is a caution. So if you're trying to find the derivative of f times g, it is not equal to the derivative of f times the derivative of g. You cannot do that. Just like if you're trying to find the derivative of a quotient, if you have a fraction, you cannot just take the derivative of the numerator and divide it by the derivative of the denominator. So that's where you're going to have to learn these two rules. Remember, these are shortcuts. If you start complaining and moaning about these rules, remember it could be worse. You could be back to the definition of the derivative, the limit as h approaches 0 of f. And I mentioned this, not all rules are going to seem like shortcuts. All right? For example, first rule is the product rule. So if you're trying to find the derivative of f times g, you have to take the derivative of f, which is your first function, multiply it by g. Add it to the first function f, multiplied by the derivative of the second function g. So f prime g plus fg prime, or a little saying I like to use is fig figgy. So fig figgy. Again, just a word to help maybe you remember the product rule. Fig, the I being your prime. F prime g plus fg prime. So there's your fig figgy. All right? Second is how you handle when you have to take the derivative of a quotient. So when you have f divided by g. So you have to take the derivative of the numerator, which is your f prime, multiply it by the denominator, minus the numerator, which is f, times the derivative of the denominator, all over the denominator squared. That is your quotient rule. Notice the numerator looks a lot like fig figgy, looks a lot like your product rule, except you have a subtraction sign. All right? A little saying I like to use, a little song, I would sing it, but I'm not going to. Low, d high, minus high, d low, square the bottom, and away you go. I don't know, the away you go just adds something to it. So again, just like I use fig figgy for product rule, low d high minus high d low, square the bottom, and away you go. Just a little phrase to help you possibly remember the quotient rule. This is what it means. Low is your g. It's the function on the bottom. D high, derivative of the highest one, derivative of the numerator. So low d high, that's your g f prime. Because again, you're just multiplying, so whether you write f prime g or g times f prime, they're still equivalent. So low d high, minus high, which is your f, d low, which is your g prime, square the bottom, and away you go. Again, I don't care how you remember it. The thing is, you have to remember these rules. Okay? So for example, let's take a look. Now, there is a common derivative. Some derivatives, yes, you can keep on coming up with them over and over again by using your power rule or product rule or whatever. There's just some derivatives that will make your life a lot easier if you just memorize them. One of them is the derivative of square root of x. This derivative comes up over and over again. So if you remember that the square root of x derivative is 1 over 2 square root of x, you're just going to save yourself time from coming up with it over and over again. All right, it just comes up quite a bit. So let's take a look at an example here. So I'm trying to find the derivative of a trinomial times a binomial. A lot of times, guys, in these problems, yes, there is more than one correct way to come up with a derivative. For example, we all know how to multiply and multiply a trinomial times a binomial. You could multiply this all the way out, but as you know, multiplying trinomials and binomials is not the easiest process, or it's not too hard, but again, it does take some time. So I want to use my product rule. So again, when you are dealing with product and quotient rule, always write the rule right in front of you. Write it for every single problem. So the rule I'm going to use is f prime g plus fg prime. So my f is my first function, g is the binomial. So before you start using your product rule, the first thing you're going to do is you want to identify which function is f, which function is g. So f is my trinomial of x to the third minus 2x plus 1. So that's my f. G is the binomial, which is x to the fourth plus x. So there's my f and g. Now I want to identify my f prime and my g prime. So I can differentiate f by using your power rule. So what's the derivative of x to the third going to be? The derivative of x to the third is just going to be a what? 3x squared. The derivative of negative 2x is minus 2. And the derivative of 1 is just going to be 0. So there's your f prime. G prime, what's the derivative of x to the fourth? 4x to the third, good. And then derivative of x is just what? 1. So now you know f, you know g, you know f prime and g prime. Now we're going to substitute into your actual rule itself. So we're going to go ahead and plug it into your product rule. So f prime we identified as 3x squared minus 2. G is the x to the fourth plus x. F is the trinomial, which we identified as x to the third minus 2x plus 1, times g prime, which we identified as 4x to the third plus 1. There's your derivative. You do not need to multiply it out. If you're dealing with a multiple choice problem and you see all the answer choices are multiplied out, then do it. But it's okay to leave it alone. I'm confident that we all know how to FOIL, distribute, and all that stuff. So any questions on how we use it? But the big thing, guys, I'm emphasizing, always write the rule in front of your face first. Identify f, f prime, g, and g prime. Then substitute. It's too much to do it all without writing stuff down. I know some of you are going to fight me on writing stuff down. You already do. And that's going to be your biggest downfall in calculus. Those of you that still continue to choose not to listen about writing stuff down, you are going to be in trouble. All right? So write the rule down. Questions? All right, let's look at B. So the problems when we were looking at fractions, I was having you take these larger fractions and split them up into smaller fractions. That only works if the denominator is a single monomial. This denominator is a binomial. So you're going to have to approach this by using your quotient rule. You're dividing. Always check to make sure, if you can, simplify your fraction if you can. You can't simplify this. But try and simplify first if you can. So you're going to have to use your quotient rule. So there's your low d high, so there's your f prime g, minus high d low, f g prime, square the bottom, and away you go. So there's your quotient rule. So remember, f is the numerator, g is the denominator. So just like we did with the product rule problems, what you want to do is identify f and g first. So f is the numerator. So then what is f prime going to be if the numerator is x squared plus 1? Well, what's the derivative of x squared? 2x. The derivative of 1 is 0. G is the denominator of x squared minus 1. So what's the derivative of x squared? The derivative of x squared is 2x, and then the derivative of minus 1 is 0. So now, just like I did with the product rule, you want to substitute f prime g, f g, substitute into your quotient rule. So f prime is 2x times g, which is x squared minus 1, minus f, which we identified as x squared plus 1, times g prime, which is 2x, all over the denominator squared. Okay? Questions on how I substituted into your quotient rule? Yep.
So you don't FOIL out the denominator yet?
Not yet, no. All I did was I substitute. I haven't done any simplifying just yet. All I've done is I've plugged everything into the rule. Now, what you want to do, you want to get your fraction in simplest form. The only way you can do that is to simplify this numerator. Now, there's a couple ways you could do this. Just an algebraic trick I want you to be comfortable with, because when you get into your e to the x's and your exponential functions, this is an algebraic way you're going to be handling simplifying. Yes, you could distribute the 2x and then combine like terms, or notice what's in common in the numerator. You have a 2x in common in everything in the numerator. So what you could do is you could factor a 2x out of everything in the numerator. And when you factor a 2x out, that's going to leave me with an x squared minus 1 minus x squared plus 1. This is an alternative to having to FOIL and distribute. So if you have a common factor, especially when we get into those exponential functions, this is going to be a much easier approach than distributing. So now, notice what's going to cancel in the numerator. I have the 2x on the outside. Well, what's going to cancel inside my brackets? X squared. And I'm left with a what? Negative 1 minus 1, which gives me what? Negative 2. And negative 2 times 2x is a negative 4x over x squared minus 1 squared. But that's your quotient rule. Okay?